Now that we've looked at the graphs of sine and cosine, now we're going to look at the graphs of tangent, cotangent, secant, and cosecant functions. So obviously the tangent and cotangent functions are going to be interrelated because they are reciprocals of each other. Looking at their graphs, this is a graph of the tangent function. If you're looking at your unit circle, there are spots where the tangent function is undefined. These undefined values give you your vertical asymptotes. So obviously you can see that this is just going to keep repeating itself. Since the cotangent is 1 over tangent, the graph looks pretty similar, but notice here the vertical asymptotes for the cotangent graph actually occur where the zeros are located on the tangent graph. So if you notice here, this is my vertical tangent for the cotangent, my vertical asymptote, sorry, I said that incorrectly. And notice that actually occurs where tangent equals 0. And that makes sense because if you're doing the reciprocal of that, you're doing 1 over, 0, which doesn't work, it's undefined. Okay, so connection between those two, notice they still have that same pattern there. One just is going a different direction versus the regular tangent function. So tangent x has vertical asymptotes. The vertical asymptotes occur on multiples of pi over 2. So it's going to give you, your vertical asymptotes there so you can see them. And so say I take 3 times pi over 2, that's also going to end up being, where it has a vertical asymptote. The cotangent graph, like we said, is where it occurs at 0. So if we're looking at our graph here, this is going to be at every pi value instead of every pi over 2. So like I said, connected to each other. Looking at sine and cosecant together, notice here the green is my sine function, that's my wave. The cosecant is obviously my blue u's that are going back and forth there. Notice they are connected at the minimums or maximums of the cosecant, and that happens to match up with the waves of our sine function. You do have every now and then some vertical asymptotes, and that just happens to occur wherever the sine value equals 0. Again, that makes sense because it's the reciprocal, so you'd have 1 over x. Cosine and secant have a similar pattern. They're just shifted over by pi, and we already knew that from the sine and cosine function there. Again, same pattern. Wherever the cosine value equals 0, you have a vertical asymptote, which is going to change the branches of that different graph. There are going to be times when you will have to solve a trig equation algebraically, and it's based on your unit circle. For instance, let's say that we have the secant value of x equals 2. So when we're looking at this, we're going to be trying to use using the unit circle based on an interval, which I forgot to give you, 0 to pi over 2. So looking at that, 0 to pi over 2 means that I'm going to be in quadrant 1 of my unit circle because 0 starts on the far right, pi over 2 is technically like your y-axis. So I'm going to draw a reference triangle, in which doesn't really matter, what it looks like necessarily, but the main thing to remember is secant x equals hypotenuse over adjacent. So if this is supposed to equal 2, the easiest way to look at this is to set h equal to 2 and a equal to 1. And I say that because obviously 2 divided by 1 gives you 2. It's something easy to use, easy numbers. So I'm going to label my triangle. Now, we are trying to figure out that theta value. So when I'm looking at this, I actually go back to the original 3 trig functions where I'm using SOHCAHTOA. So if I'm looking at this, because it's secant, I already know I'm going to be using cosine. So I have cosine x equals 1 over 2. Because I'm looking for that angle measure, I'm going to use that unit circle and figure out within that quadrant 1, where on my unit circle does the cosine value equal a half. Or, if all else fails, you could also use a calculator, depending on how it's phrased. You're going to take the inverse cosine of a half in order to get that radian measure. The reason why I don't want you to necessarily use the calculator is because it won't give you an exact value. That's where that unit circle is going to be handy. Using that unit circle, we will say that x equals pi over 3. So that's using your unit circle and figuring out your secant value and stuff. If all else fails, the other thing that you could do is use Desmos. I could have my secant value of x here, and then I could also set it equal to 2. When I'm setting it equal to 2, I'm going to have y equals 2, and I'm going to figure out, based on this, looking at my graph, where that intersection actually occurs. But the hard thing is that value occurs several different times, so you're going to have to know where your quadrant is and what quadrant you're actually in on your interval. So if you noticed here, looking at the graph here, it does also occur at pi over 3. Like I said, based on the unit circle, but not every time will you have Desmos. So that's our graphs of tangent, cotangent, secant, and cosecant.